Hello students, welcome once again to a short video on A-level organic chemistry. As you can see that my topic for today is electrophilic aromatic substitution of A-level organic chemistry. So what is new or what is different in this video? There are so many videos which explain the electrophilic aromatic substitution. But what I'm going to focus on is what they really don't explain, and then it becomes difficult for the students to understand the concept. So let's dive in. So as an example, I have taken the nitration of benzene. Now as you can see here that I have shown the benzene ring and it reacts with concentrated HNO3 under certain specific conditions, and you get an NO2 group attached to the benzene ring and water. The question is that the students don't see any NO2 group in HNO3. So how did you get the NO2 group? So to understand this, it would be easier for you if you wrote HNO3 in the form of HONO2. HONO2 is in fact HNO3. But it becomes easier to understand that it has an NO2 group. And then the OH part combines with the H part of benzene, forming water, and NO2 group comes in the place of the hydrogen. That is one way you can remember this reaction. Another thing is that if you go to the mechanism of this reaction, then the electrophile used in this reaction is NO2 plus. And the NO2 plus, the nitronium ion, is formed by the reaction between nitric acid and the concentrated sulfuric acid. I've written down the reaction that you have seen often. There's nothing new about this. But what I'm going to explain to you is the mechanism part. So what you find in the textbooks is that the NO2 plus is the electrophile, and the benzene ring, the pi electron cloud of benzene, attacks the NO2 plus and it forms this intermediate, which you find that there is an H, there is an NO2, there is a positive charge, but the positive charge is not spread throughout the benzene ring, and it just covers this much region. It covers this much region from here to here, but it doesn't cover this region, and there's a positive charge. What I want to focus on this is what exactly is this and how did you actually get this, so that you don't have to just mug it up. The explanation is as follows. The explanation is that it would be better for you to not write benzene in the form by drawing a circle over here, but actually showing three alternate double bonds. As you know, this is also a way benzene can be represented. Then you show that the electron pair from one of the double bonds is used to form a bond with the NO2. So that leaves only now two bonds, because one electron pair has been used to form this particular bond. So now we have only two bonds, and now because this electron pair has moved in fact from this position, and it's being used to form a bond with NO2, so you will actually get a positive charge on this point, on this carbon. And you can see that here there's a deficiency. There are only three bonds because one is a hydrogen which is not visible. Here already there are four bonds, so you won't get a positive charge here. So the positive charge is here. Now you can move this electron pair to this position. If you do that, you will get a double bond here. And because now this point has only three bonds, one is the invisible hydrogen over here, so you'll get a positive charge here. Then in the third structure, you can move this double bond here, so that you will get a double bond here, and the positive charge moves here because this is the electron deficient carbon. So what you find is that the positive charge is present here, after that it is present here, and after that it is present here. So in fact the positive charge is delocalized over these three positions, but you won't find that there is formation of double bond here in this region, because already the four bonds are there. So now you can visualize that the positive charge is spread. The positive charge is spread over this region, and these are called as resonating structures. You don't need to know about resonating structures in your A-level study of chemistry, but this is not a very difficult concept which cannot be understood. So if you understand this for your knowledge, it would be good. So this is the real situation, and this is shortened in this form, that the positive charge is spread in this region. So if you understand these three resonating structures which can be formed, you will easily understand the concept behind drawing this kind of intermediate. So this is what I wanted to explain you. The rest of the things are something which is explained in the textbooks, and it's not something where I want to add anything new. And what happens is that in the next stage, because the benzene ring is very stable, so it wants to get back to its stable structure. The electron pair forming the CH bond again moves inside the ring, completing the system of the three alternate pi bonds. So once again a stable benzene ring is formed, and the hydrogen, because it's losing its electron pair, is lost in the form of H plus. And instead of drawing this, you could also draw with the three alternate bonds. So if you understand this, it will be easy for you to grasp the meaning behind drawing the intermediate the way it is shown in your textbooks. Hope it makes sense and you have grasped this idea, and the concept of drawing this kind of intermediate would have become clear to you. Thanks very much. Thanks for watching. If you like it, please comment on this video. Thanks again.